Okay, so I've been asked to explain myself, basically. So this is the solution to a problem I was set. The problem was 2 raised to the power of x plus 2 plus 2 to the power x is equal to 5. Okay, so this is the line 1 of my solution, and this is just the problem that was set, so there's nothing to explain here. Right, so I want to talk a little bit about the law of indices. So I'm actually going to type that out because my writing is terrible. Okay, so the first thing I want to say is, what is an index? So this bit on the top that's elevated above the line is your index, and this here is your base. So this is the base, and this is the index. And we have another index here. And we have another base here. Okay, so I hope now we know what the base and the index is. So if we have a raised to the power of b, what we're saying is we've got a multiplied by a multiplied by a, and we're multiplying by a b times. So let's do a few quick examples. So 2 squared means 2 times 2, which is equal to 4. 2 cubed is equal to 2 times 2 times 2, which is equal to 8. And 2 to the power 4 is equal to 2 times 2 times 2 times 2, which is 4 lots of 2, which of course is equal to 16. Alright, so what we're doing here, if we multiply by the base, we're basically adding 1 to the index. So we start with 2 to the power 2, and we multiplied by 2, we got 2 to the power 3, which is 2 plus 1. Now we could go and generalize this a bit further, and let's say we've got a raised to the power 2, and we want to multiply this by a cubed. Well, that's equal to a times a, which is a squared, or a to the power 2. And now we're multiplying, so we need another multiplication sign here. And then we've got a cubed, which is a times a times a. And that's equal to, how many a's have we got? 1, 2, 3, 4, 5. So that's equal to a to the power 5. But a to the power 5 could also be written to a to the power 2 plus 3, because 2 plus 3 is 5. Which brings us to our first law of indices, that a raised to the power b multiplied by a raised to the power c is equal to a raised to the power of b plus c. Now let's say we've got 2 to the power of x plus 2. We can go backwards and say, well, how did we get to 2 to the power x plus 2? Well, isn't that the same as saying 2 to the power x multiplied by 2 to the power 2. As you can see, a to the power b times a to the power c is a to the power b plus c. So 2 to the power x multiplied by 2 to the power 2 is the same as 2 to the power x plus 2, which means 2 to the power x plus 2 is the same as 2 to the power x multiplied by 2 to the power 2. And that brings us to our next line. Now the only difference is, instead of using a cross multiplier, I've used a dot multiplier. So if we've got AB means A multiplied by B, which is the same as saying A times B, which is the same as saying A times B. They're all just different algebraic notations for meaning the same thing. Why we've got different ways of saying the same thing is complicated and way beyond the scope of this video, but you'd really need to get into linear algebra to know the difference between a cross product and a dot product, but there you go. So we have our second line. I'm just going to copy that second line down. Okay, so these two lines have been explained, so let's go to the next line. Right, so what have I got here? I've got 2 to the power x times 2 to the power 2 plus 2 to the power x. Okay. Let's talk about the distributive property of multiplication. It means A multiplied by B plus C is equal to A times B plus A times C. Now let's see if we can intuit why that is the case. Okay, let's try something like 2 times 3 plus 4 is equal to, so we know from our order of operations that we have to solve the brackets first. So we solve the brackets and that gives us 2 times 7, which is equal to 14. Okay, but what have we done by solving the brackets first? We've basically said that 2 is multiplied by everything in the brackets, the whole thing. So this is the same as 2 times 3 plus 2 times 4. And let's just prove to ourselves that that works. But first, let me write 4 properly. So 2 times 3 plus 2 times 4 is equal to 6 plus 8, which is equal to 14. And 14 is the same as 14. That's just to prove to ourselves that that works. Now, the opposite of distribution is factorization. So if we want to go from here back to here, what we're doing is we're pulling this A out. So A times B plus A times C is equal to A times all of B plus C. And that's basically what I've done here. So we've got 2 to the power x multiplied by 2 to the power 2 plus 2 to the power x, and that's equal to 5. But we haven't got this 2 to the power x multiplied by anything, but if you multiply any number by 1 it doesn't change, so we can imply that that's 2 to the power x times 1. And now if we pull the 2 to the power x out, we have 2 to the power x into 2 to the power 2 plus 1, which is equal to 5. And that's basically all I've done over here. So hopefully you can see that that's the same as that. So that's this line explained. Okay, now in this line, so I've done this one. Right, so now we're on to this next step. So what we've got in the brackets here, we've got 2 to the power 2 plus 1. And this is just arithmetic. 2 to the power 2 is 2 times 2, which is 4. And we add 1, and 4 plus 1 is equal to 5. So I've got 2 to the power x multiplied by 5 is equal to 5. And just for neatness, I've written it the other way round because of the commutative property of multiplication. And the commutative property of multiplication basically says a times b is equal to b times a. In other words, 2 times 3 is equal to 3 times 2. Most people are happy with that, but just in case you're not, let's draw a little representation. Okay, so here we've got 1, 2, and here we've got 1, 2, 3. And so this can be considered as 2 times 3, or 2 lots of 3. You've got 3 here and you've got 3 here. Or you could consider it as 3 times 2 because you've got 3 lots of 2. So if you're counting down, you've got 1, 2, 3, 4, 5, 6. Or if you count the other way, or we could count the other way and we could say 1, 2, 3, 4, 5, 6. Okay, so either way, excuse the terrible handwriting, either way you can multiply either way round and it will give you the same answer. So a times b is the same as b times a. Which means 2 to the power x times 5 is equal to 5, so this is the same as 5 times 2 to the power x is equal to 5. And that's basically all I've done here. Right, so that's another line explained. And now we're getting to the really easy stuff now. Okay, so what I've done now is I've basically divided both sides by 5. So if I divide that side by 5, I divide that side by 5. Well, 5 divided by 5 is 1, and 5 times 2 to the power x divided by 5, the 5's cancel, and you're just left with 2 to the power x equals 1. And that's our next line. This is just to show where we've got to. Okay, so now we've got our last step. Let's just do a bit more on the law of indices. So a is equal to a raised to the power 1. Actually, let me move this down and go up. Right, so if I multiply both left side and right side by a, I can say a times a Well, we've got two a's multiplied together, so that's just a squared, or a to the power 2. And again, let's multiply by a. So this is a times a times a, which is equal to a cubed. And if we multiply again, we get a times a times a times a, which is equal to a to the 4. And I think you can see now where this is going. We can go as high up as we want. But now what happens if we go the other way round? Let's divide by a. So a times a times a times a divided by a, well, and a will cancel from the top and the bottom, and you'll just have a times a, which is a to the power 3. So dividing by a means we're taking 1 away from the index, just as multiplying by a added 1 to the index. So we divide by a again, and we get a times a is equal to a squared, and we divide by a again and we get a equal to 1. But now what happens if we divide by a? Let's continue the pattern. So this is a divided by a, and that's equal to, well, we've got to take 1 away from the index, so that will be a to the power 0. And if a can be any number, and we can cancel a from top and bottom, then that just equals 1. So any number raised to the power 0 is equal to 1. I should give the caveat that that's not the case with 0, but that's subject for another video. But any number other than 0 will be equal to 1, and that's just because 0 divided by 0, well, that's undefined. So if 2 to the power x is equal to 1, then what value for x will make 2 to the power x equal to 1? Well, anything raised to the power 0 is 1. So x is equal to 0, which is our final answer. Now, what I usually do, or what I like to do when I have the time, is to check that my answers are correct. And what I do then is I substitute my answer back into the original question. So the original question is 2 to the power x plus 2 plus 2 to the power x is equal to 5. Now we've already calculated that x is equal to 0, so let's substitute 0 for x. So we get rid of the x and we put in 0. So 2 to the power 0 plus 2 to the power, and we know x is 0, so we get rid of the x and we put x is 0. And that's all equal to 5. So that's basically this line here. Well, 2 to the power 0 plus 2, what 0 plus 2 is just 2. So that's the same as 2 to the power 2 plus 2 to the power 0 is equal to 5. And 2 to the power 2 is just 4, and 2 to the power 0 is 1. So 2 to the power 2 is 4, 2 to the power 0 is 1, and that's all equal to 5. And that's this line here. And 4 plus 1 is equal to 5. There you go. 4 plus 1 is equal to 5, and 5 is equal to 5. So we know we've got the right answer. And that's all there is to it. I hope you enjoyed this video. Hope it was informative in some way. And enjoy your maths, and maybe I'll see you in some future video. Take care now. Bye bye.